Hello, in this video we're going to work through this question right here. We're going to find the length of AB and AC, and note not in terms of x. So what it's saying is it doesn't want you just to apply Pythagoras' theorem to calculate AB in terms of BC and AC. So what jumps out at me right away is the fact that this is a 45, 45, 90 triangle. So there's two ways that students usually approach this problem. So method one is going to rely on the fact that we notice that this is a special triangle case. So since it's a 45, 45, 90, that means that the opposite and adjacent are equal. So here, if 2x minus 3 is one side and x is the other, I can make the statement that 2x minus 3 has to equal to x. And then we can quickly see here with some algebraic manipulation, x is 3. Therefore, if x is equal to 3, we know that AC is going to equal to 3 and BC will equal 3. And we calculate these simply by summing it back into both of these expressions. I have a nice little check here, and the check is that those are the same. So now, if we know BC and AC, a couple ways to find the AB. Let's go back to blue here. One way to find AB here is you could recognize this is a 45, 45, 90. So if I just come up here really quickly and I draw out that triangle, 1, 1, root 2, 45, 45. So in my triangle that's given, x is 3. So to go from 1 to 3, we have to multiply by 3. So if I have root 2 for my hypotenuse in my special triangle base case, it's going to be 3 root 2. So again, this is where sketching out that special triangle is useful. If let's say you didn't remember this or didn't know this little diagram here, what you could do is you could say that AB squared is equal to 3 squared plus 3 squared. So AB squared is equal to 18. So AB is equal to the root of 18. And again, it would be perfectly acceptable to leave it in this state, but one algebraic technique that we've learned is that we can rewrite this as 9 times 2. Let's just come back up here. So therefore, we can take, this is the same as saying AB is the square root of 9 times the square root of 2. So we get 3 root 2. Again, both this form and this form are acceptable. This is a mathematical technique which we haven't formally explored, but we've seen come up a number of times in the work that we're doing. Okay, let's look at the second method that students use for this. And I say students, you know what, I should say anyone uses for this. So the second technique that some people would use is, well, if this is 45 degrees and we have the opposite and the adjacent, we can then say tan of 45 degrees is equal to x over 2x minus 3. And we could get our calculator out and take tan of 45, which would give me 1, is x over 2x minus 3. So then multiply both sides by 2x minus 3, so I get 2x minus 3 equals x. And from this point on, it's the same question. So notice this is another useful way, another approach that is very valid for this problem. I hope this video helped.